Hi students, problem number 7. An electric dipole with a dipole moment 4 into 10 power minus 9 coulomb meter is aligned at 30 degree with the direction of a uniform electric field of magnitude 5 into 10 power 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. Very simple question it is, and very interesting and easy also. Now, what will happen if a bar magnet is suspended in the classroom or in this room? Due to the presence of the Earth's magnetic field, the magnet will rotate for a few seconds and then finally it will align along the Earth's magnetic field, that is north-south. In a similar way, what will happen when a electric dipole is aligned in the electric field, uniform electric field? So it is aligned at 30 degree. Will it rest as it is? No. It will oscillate simple harmonically. It will exhibit angular SHM and finally it will align along the direction of the external uniform electric field. So it is going to experience a torque. So what is the magnitude of the torque we have to find out. So what about the given quantities we have to write? First, the dipole moment, magnitude of the dipole moment is given. So this is 4 into 10 to the power of minus 9 coulomb into meter, and the angle theta is equal to 30 degree, and the electric field magnitude is 5 into 10 power 4 Newton per coulomb. The torque is now asked. Torque tau we have to find out. So the torque acting on the dipole. So the torque acting on the dipole is given by tau. So the magnitude of the torque is what? P into E into sine of theta. So in place of P, I am going to substitute 4 into 10 power minus 9 into electric field is how much? 5 into 10 power 4 into sine 30. So now you will see that this 4 multiplied by 5 is 20. So I can write 20 into this sine 30 is how much? 1 by 2. Sine 30 is 1 by 2. Into remaining is what? 10 power minus 9 plus 4. So this is minus 5. Okay students. So this 20 by 2. So we can cut this 20 by 2 10 times. No. Therefore, torque is now equal to 20 by 2 is 10. Okay. 10 into 10 to the power of minus 5. Or the magnitude of the torque is equal to 10 power minus 4 Newton meter. So the unit of torque is what? The unit of force multiplied by the perpendicular distance. So it is Newton into meter. So it's very important, though it looks very simple, it is very important. I hope you must have understood them fine.